Welcome back students for part 3, the chapter Acids, Bases and Salts. This is chapter 5 in your Science and Technology book of Standard 9. If you haven't already watched part 1 and part 2, please go to the YouTube channel and watch them first. Let's start with this final part of this chapter. Let's look into some details of salts, the types of salts, acidic, basic and neutral salts. There's a little activity. This will be done in your lab at school and your teachers will help you to understand this, but let's go through the theory part of it. Prepare 10 ml aqueous solution of 1 gram salt, that is sodium chloride, ammonium chloride and sodium bicarbonate, and measure pH of each solution by means of pH paper. Are the values same for all these three? Classify the salts on the basis of pH values. Now we've seen the salts are formed by reaction between acid and bases, and there is a water produced. Though this reaction is called neutralization reaction, the salts produced are not always neutral. A neutral salt is formed by neutralization of strong acid and strong base by strong base, and the aqueous solution of neutral salt has pH of 7. We know the neutral pH is 7. An acidic salt is formed by neutralization reaction between strong acid and a weak base. The pH of aqueous solution of an acidic salt is less than 7. We know that acidic substances, whether it is a acid or it's salt, the pH is less than 7. On the contrary, the basic salt is formed by neutralization reaction between weak acid and strong base. The pH of aqueous solution of the base and basic salt is more than 7. Now classify the following salts into types of acidic, basic and neutral. And here is a list of salts. Now the correct answer to this is sodium chloride is a neutral salt. Sodium acetate is basic salt. Ammonium chloride is acidic salt. Calcium carbonate is basic salt, and sodium carbonate is again basic salt. Now your book mentions about these chemical reactions and it asks you to fill up the blanks. There are carbonate salt of metal plus dilute acid on left side, and on the right side there is another salt of metal plus carbon dioxide. I looked at these reactions carefully. I think the lower two reactions in top 4, they need to have water and CO2 on the right side as well. So have a look at it yourself. Do try and balance these reactions on both sides and see what you feel. I'm giving the answer here for both top 3 blank spaces and the bottom 3 as well. If there is anything mistake, if you think I'm wrong, please let me know in the comment. There's another activity to be done. Again, you are meant to do this in your labs. Let's go through the theory part of it. Take some crystals of blue vitriol in 2 test tubes. Add some water in 1 test tube and shake it. What do you see? What is the color of the solution formed after mixing blue vitriol with water? Now heat the other test tube on low flame of a burner. What did you see after heating? What change did occur in the color of blue vitriol? What did you see in the upper part of the test tube? When the second test tube cools down, add some water in it and shake. What is the color of the resulting solution? What inference can be drawn from this observation? Let's look into some explanation of it. On heating, the crystalline structure of blue vitriol broke down to form a colorless powder and water came out. This water was part of the crystal structure of blue vitriol. It is called water of crystallization. So heating separates water from the blue vitriol, and that's why it becomes colorless powder. On adding water to white powder, a solution is formed which has got the same color as the solution in the first test tube. Now from this we come to know that no chemical change has occurred in the crystal of blue vitriol due to heating. Losing water on heating blue vitriol, breaking down of crystalline structure, losing blue color and regaining blue color on adding water are all physical changes. There is no change in the chemical structure. So look at the chemical equation given under this diagram. CuSO4 5H2O, that's blue vitriol in crystalline form with water. Heating will change it into two separate compounds, CuSO4 plus 5H2O. So the color changes from blue to white, and when you add water to the white powder, then it again turns blue. Now there is an activity for you. Repeat the above activity for ferrous sulfate, sodium carbonate, and write chemical equations. So, you can do this in your chemical labs, but the chemical equations will be exactly same. Only thing is that water component will be different in sodium carbonate and ferrous sulfate. I have searched for you guys, and this is what the water component will be, and you can write rest of the equations exactly same as the previous one. There's another experiment to be performed here, which needs apparatus including evaporating dish, Bunsen burner, tripod stand, and wire gauze. And you are going to need alum for this. The procedure is take a small piece of alum in evaporating dish, keep the dish on tripod stand and heat it with the help of burner. What did you see in a dish? What is meant by puffed alum? Now let's look into this. Ionic compounds are crystalline in nature, and these crystals are as a result of definite arrangement of ions in their structure. In the crystals of some compounds, the water molecules are also arranged in their structure, and this is a water of crystallization. This is present in a definite proportion of a chemical formula in each compound, and it's indicated by a chemical formula. Now have a look at it, how it's shown. Crystalline blue vitriol is copper sulfate and 5 water molecules. Crystalline ferrous sulfate, which is green vitriol, is ferrous sulfate and 7 water molecules. Crystalline washing soda, it's sodium Na2CO3 and 10 water molecules. Crystalline alum is K2SO4 Al2SO4 3 and 24 water molecules. So crystalline substances do have water molecules, and the molecule of water of crystallization are a part of the structure of the crystal, and on heating or just by leaving the crystalline substance as they are, the water of crystallization is lost slowly, and crystalline shape is also lost, because the crystalline shape is as a result of combination of that chemical compound with water molecules. Now let's learn a little bit about electrical conductivity of ionic compounds. And there's another activity which you will need to do in your lab again. Prepare a 1 gram salt in 50 ml water. Make a solution. Take 2 electrical wires. Connect one of it to positive terminal of a battery, 6-volt battery. Connect other wire to a negative terminal of the battery and include one switch and one holder with an electric bulb as shown in this figure. Now remove the insulating cladding from 3 centimeter portion of the free ends of two wires. So the wire is open at both ends for 3 centimeters. Take the salt solution in 100 ml beaker and immerse these two wire ends into this solution with the help of a support as shown at the top of the beaker. There is a support here. Now switch on the current and note whether the bulb glows, whether the bulb starts shining. Repeat the same procedure using 1 gram copper sulfate, 1 gram glucose, 1 gram urea, 5 ml dilute hydrochloric acid, that is H2SO4, and 5 ml dilute sodium hydroxide, each in 50 ml of water, and make note of your observations. And at the end of it, clean the beaker and all the parts, uncovered parts of the wire with water whenever you change the solution, otherwise your findings will be mixed up. Now after completing this experiment, there are a couple of things you have to look into. With which solutions did the bulb glow? Which solutions are electrical conductors? It's actually the same question, just put into different wordings. The bulb glows only when electric current passes through the bulb, and this is going to happen when there is a complete electric circuit. In the above experiment, the circuit is complete when aqueous solution contains sodium chloride, copper sulfate, H2SO4, which is sulfuric acid, and sodium hydroxide. So these are conductors of electricity. Now electrons, they conduct electricity through the wires, and ions conduct electricity through the solution. Electrons leave the battery from negative terminal and they complete the electric circuit and enter the battery at the positive terminal. Now the two wires or rods or plates which are immersed in the solution, when the solution is a part of the circuit, these wires are called as electrodes. They are usually made up of conducting solid. The electrode connected to negative terminal is called cathode, and electrode connected to positive terminal of battery is anode. So remember, positive electrode anode, negative terminal electrode cathode. Now why does the electric circuit is complete on immersing the electrodes in some liquids and not the others? Let's go through this. Dissociation of ions and electrical conductivity is the concept we need to know to answer this. In the experiment we just read, it's found that aqueous solutions of sodium chloride, copper sulfate, sulfuric acid, and sodium hydroxide are electricity conductors. Now sodium chloride and copper sulfate are salts. Sulfuric acid is strong acid and sodium hydroxide is strong base. Now salts, strong acids and strong bases, they dissociate completely in aqueous solutions. That is why aqueous solutions of all these three contain large numbers of anions and cations. A characteristic of the liquid state is the mobility of the particles, and due to mobility, positively charged cations in the solution get attracted to negative electrode or cathode and move towards the cathode, whereas negatively charged anions move towards anode. The moment of ions in solution to these electrodes results in conduction of electricity through the solution. Now that's how the electricity is conducted through the solution. Let's look into electrolysis. It's a small procedure. Take a solution of 1 gram copper sulfate in 50 ml water in a 100 ml beaker. Use thick plate of copper as anode, that is positive electrode, and carbon rod as cathode, that is negative electrode, and arrange the apparatus in the way it's shown in the diagram. Now, when the circuit is on, let's see what happens. The copper appears to have deposited on the portion of cathode, that is negative electrode, inside the solution. How does that happen? When the electric current is started, the cations, these are copper ions, Cu++ ions, they travel in the solution and get attracted to cathode. At the cathode, the electrons which are coming out from cathode, they combine with copper ions and they give rise to copper atoms. Deposition of copper takes place on the cathode. Even though the copper ions in the solution are used in this manner, the color of the solution doesn't change, because when the electric current is on, the electrons are moved from copper atoms of the anode and sent to the battery through the electric wire. So the copper ions travel through the solution and electrons travel from the copper electrode to the battery, two opposite directions. So copper ions formed, they go into the solution. In this way, decomposition of the solute in the solution takes place in presence of electric current. This is called electrolysis. There are two parts in this process. These are the cathode reaction and anode reaction. Look at the reactions which take place at cathode and anode. The copper ions, they combine with electrons and they give rise to copper atoms. At anode, the copper atom splits into copper ions and electrons. The copper ions go into the solution and electrons go towards the battery through the copper electrode. Important points to remember: it's necessary for liquid to have a large number of dissociated ions for electrolysis to take place. Therefore, substances which undergo dissociation to large extent in liquid state or a solution are called as electrolytes. Salts, strong acids and strong bases are electrolytes because they dissociate to a great extent in solution. Their solutions have high electrical conductivity. In other words, electrolytes are good conductors of electricity in solution or liquid state. An assembly that consists of a electrolyte container and electrodes dipped into the solution is called as electrolytic cell. Now, if the electric current is passed through the electrolytic cell, that is the electrolyte solution and two electrodes dipped in it, if the electric current passed for a long time through this, what will happen at the anode? Now we know that copper ions are formed at copper electrode and they are dissolved in solution and they are attracted towards carbon electrode. So they get deposited on the carbon electrode. So slowly the copper electrode will lose more and more copper atoms, which are converted into copper ions and electrons, and copper electrode will lose its mass. It will become thinner and thinner if the electric current is passed through the electrolyte cell for a long time. Now the next point is, would water be a good conductor of electricity? If pure water is used in electrolyte cell, the current does not flow even on putting on the switch. Now we can say that it's a bad conductor of electricity. The concentration of hydrogen and hydroxyl ions formed by dissociation of water is so low, it's only 10 raised to minus 7 moles per liter for each ion. That's why it is a bad conductor of electricity. However, the electrical conductivity of water increases if we mix a small amount of salt or strong acid or base into the water, and that will lead to dissociation of the salt or strong acid or base, and they'll produce electrolytes, and then this water will carry the electricity. Now there is an experiment described in your book about electrolysis of water. Here 2 gram salt is dissolved in 500 ml of water. Take 250 of this and put it in a 500 ml capacity beaker. Connect two electrical wires to the positive and negative terminal of battery. Remove the insulating cladding from both the wires 2 cm from the ends. These are the 2 electrodes. Fill 2 test tubes up to the brim with the prepared dilute salt solution. Now we got a salt added to the water, so fill them in 2 test tubes. Invert the test tubes on the electrodes without allowing any air to enter. Now look at the diagram. The electrodes are dipped into the water and the 2 test tubes are inverted without allowing any air. Start the electric current with 6 volt potential difference from the battery and see what happens in the test tubes. Now see if you can see any gas bubbles at the electrodes in the test tubes, and see if these gas bubbles are heavy or lighter than the water, and the volumes of the gases collected over the solution in the 2 test tubes, are they same or different? Let's look into the details. Now you can clearly notice the volume of the gas formed near the cathode is double than the gas formed near the anode. So cathode is the negative electrode, and you can see the volume of the gas formed is almost double. The hydrogen gas is formed near the cathode and oxygen at the anode. So we can say that with electrolysis of water, there is a production of hydrogen and oxygen gas. They are released at cathode and anode. So you can write the cathode and anode reactions as shown here. 2 water molecules plus 2 electrons flowing through the circuit will give rise to 2 hydrogen and 2 hydroxyl. That is the cathode reaction, because cathode will provide electrons. The anode reaction, at the anode the electrons will be given up. So 2 water molecules will release oxygen, 4 hydrogens and 4 electrolytes at the anodes. Now test the solutions in the 2 test tubes with litmus paper. What do you see? And repeat the activity using dilute sulfuric acid and dilute sodium hydroxide as the electrolyte in place of pure water. Now we know hydrogen produced near the cathode will make the solution more acidic, whereas oxygen released at the anode will not change the pH of the solution. So in a pure water it should show no change in litmus paper. I would suggest you actually test this in your experiment so you know exactly what change it makes. Now what are the applications of electrolysis? Students, this is a very important process in industry and also in small businesses. So it's used in extraction and refining of metals. In the process of refining of metals, the impure metal extracted from its ore is made anode. The salt of the metal is made electrolyte. Pure metal deposits on the cathode, like we saw in the experiment previously. Electrolysis is also used in the production of chemicals. Many chemicals like caustic soda, chlorine, potassium permanganate, ammonium persulfate, hydrogen, oxygen are produced by electrolysis on large scale. Electrolytic reduction of metals from their compounds is done using electrolysis, and it's used to obtain several metals such as aluminum is obtained from bauxite by using electrolysis. Electroplating is the process to cover article uh, that is made up of cheap metal with a thin covering of precious metals such as iron is covered with nickel or chromium, uh, of silver or gold. The article made of one metal may be electroplated to cover it by another metal. So it's used in gold plating, silver plating industry. Also, there is an electroforming process where reproduction of objects by electrodeposition on some kind of mold or form is known as electroforming. This is another application of electrodeposition. So these are few examples. There are many more applications of electrolysis you can find out from other texts or from internet. Now this is the end of part 3, and here we finish the whole chapter, acids, bases and salts. I hope you enjoyed this. For more chapters in science and technology subject, please visit my YouTube channel and also share this information with your other fellow students, with your friends. Take care. Bye bye.